we have Chiara Nosarti from the lecture in neuropsychology from the Psychological Medicine Institute of Psychiatry. And Hugo Spiers from the UCL neuroscientist from the Department of Imagining Neuroscience? Imaging Neuroscience. Well, there you go. So it's imagining and imaging, both. And Marcella Ucci, who just did research into dust mites and their lives currently. So we're going to have some information about life in the microspace. And of course Teresa Stoppani, whom most of you probably know, but who used to be here and is running a department, theoretical department, yes, at Greenwich. Architectural School of Greenwich. Okay. Yes. So shall I pass it on to you? So you say a few things.
So welcome to the Invisible. As the announcement also has been nearly invisible, we are really lucky that so many people came. And I would just like to start. We are. Why is it not working? Yeah, it's working. So I would just start with a personal introduction. Why I became very interested, more or less, in the invisible and how, or in the small. This idea of smallness and invisibility, and it actually started, the fascination and also the entrance to the invisible array is opened by dust. Dust is the smallest visible material and to the naked eye, and it contains everything, and everything can become dust. I give a sort of technical quote, what dust is, by Blackstin. He was a he was a scientist in the 30s, and he is saying all material in greater or lesser degree are more or less liable to form dusts. Dust is a degraded organized material. The immense result has been a widespread accumulation in all parts of the earth at all times of a heterogeneous mixture of dust. Can I get rid of this? Because can't I use okay, because I need my hands somehow. And so if you imagine what dust is, or if you imagine that everything can become dust, and dust is everywhere in the atmosphere, it's an incredible idea. It's an incredible material, and this is where the fascination actually began. And of course, dust is known to everyone. It's best known as a disturbance. If you have dust in the eye, you can't see. If you have dust on your computer, if you have dust on the window. But if you try to abstract from these valuations and look at it in a different way, it becomes so fascinating, because dust becomes a material, for example. Painters used it, or it becomes a material when it is witnessing past times, or historical devices, when, for example, it's analyzed by archaeologists or criminologists. Dust becomes a very, very valuable material, because it's so precise in what it is, contains all the information. And dust becomes a medium. For example, when dust is used in an airflow tunnel to visualize air movements. And dust also became a model. Dust became a model for mathematical calculations. And I will just name one of them. This is to prove the existence of the probability law. Norbert Wiener, he was a mathematician in the 40s, and he by actually using or focusing on dust, he tried to prove the existence of the probability law. This also is quite interesting because this has been applied for a formula for non-deterministic targets dynamic. So like it has been applied as a mathematical formula to track bombs or airplanes. So just to get an idea why actually dust really became a scientific model for complexity, for relativity and all this. And also it became a model, just to name another example, which is not so abstract, it became a model when size and name is exemplary for a miniaturized wireless computer device named Smart Dust, which is just been developed over the last 5 years or something. It's a small device what you can't see, and it's so light that it's actually able to stay in the air, and so it's giving information and recording information. And this is called Smart Dust. So just to give, trying to categorize what dust can do and what you can do with dust. Now, to use it or to introduce dust as a model. I mean, why I became interested in dust is, of course, it's before it settles, it moves, and this is the spatial quality which is really which is fascinating, because dust actually moves in all dimensions. So it's a four-dimensional animation of space. If you perceive dust, if you perceive space through dust, dust becomes an animation because it's actually shown. I don't know why this is not working, but normally it works a bit. It's a bit smoother and not so cut off. But the idea is that as it is moving on the screen, it forms a microspace in a way, and it is not to do with 2 or 3 dimensions. It overcomes the Euclidean idea of space, because it moves irregularly in all directions of the space. And if you look at these small particles in this way, it really becomes an exemplary for the idea of 4 dimensions. And this is what I found extremely, extremely interesting with dust. Also, the movements can't be predicted, because it is such a complex system, because all the physical, chemical, and biological and electrical charge, they all react amongst each other. So it's a sort of system of complexity. That's why it cannot be predicted where all the particles actually go. But now it's of course a problem of representation. I'm actually speaking, or the beamer is not strong enough, because I'm not speaking about the 2-dimensional representation or the 3-dimensional representation of the film. I'm actually speaking about the room the light is doing on the screen. Yeah, so there you have this 4-dimensional animation through the particles. Just to give a short example, there's a method, a technical method called particle tracking, and they are to produce these images. They are stills from a film. In order to capture the 4D movement, they need 2 orthogonal cameras. They are called 3D particle tracking cameras. So in order to actually capture this 4D movement, you need 2 cameras in exact orthogonal position. This just shows how difficult it is to visualize, or to visualize the 4 dimensions, because now visual media can actually represent these 4 dimensions, what dust can do. Okay, and now we have a break. This is a break because like the first operation to use dust is using the images and the enlargements of the small. So if we have the microscopes or the new technology of electron microscope, you have the morphology and topography you can actually study, and you get these images from the same material we have seen before. Or it becomes a landscape. And interesting is you have a scale downstairs. This represents 3 micrometers, and 1 micrometer equals 1,000th of a millimeter, which for me also already is quite difficult to imagine or difficult to relate to. I just show a few more images of dusts under the electron microscope. And always that's always given a scale, like in an architectural drawing, so you can relate to it. But still, it's quite hard to relate to. And now, to use or to decode these images, because also the scale is so difficult to relate to, I just looked at the tools, and the tools, well, not the tools, the image generation, and it has nothing to do with optics or optical device anymore. It is really a measuring tool, so either it's an electron or a needle which scans the sample, and in order to put together or to all the data of these measurements is put together to an image. So before these images are created, they were just measurements. And this, I think, it's an interesting, it's really a modern new technology. Okay, and also, I think it speaks for itself what kind of machinery you need to go into this microspace. Okay. So on the left-hand side, you just have the software, and you have the scales of the measurements, and this is generated into an image in order to read all this information at once. So actually, it's quite artificial, this image, how it's produced. This is another sample of a big electron microscope by IBM. And I would like to end with a picture IBM produced, because to prove and advert their abilities of micromechanisms or micromechanization, they produced a model of Frank Lloyd Wright's building Falling Water, and I'm sure it's known to you, to a microscale. Down you have this scale. And this is an architectural model which can only be made visible with the help of these electrons. A real built architecture entered the microarray as a miniaturized model. It introduces techniques of an architectural representation to the site of a scientific technology. In the workshop, we would like to deal with it in opposite direction. And make use of the scientific image generation to develop spatial concepts. So if real architecture has found its way to the microspace, we would just like to try it the other way around. In what way? This has to be developed. Okay. So now we are. Yeah, okay.
Unless there are some maybe questions, direct
and
to
yeah.
Bettina.
What Teresa.
Hugo or Chiara, do you have anything?
I think it's good to have it at the end.
I guess it'd be quite useful to know. You mentioned you got interested in dust. A bit more about the process by which you became interested in dust. You briefly mentioned that at the start. You said you've been thinking about architecture for a long time, but the actual dust.
Yeah.
What was the process by which you got interested in dust?
Actually, why I became interested is that I thought I was looking at clean rooms, and clean rooms are actually the new high technology spaces which have been developed this century. They have never been existed before, so it's an entirely new program to architecture. And I thought I should maybe analyze this new sort of demands of clean air in order to find new spaces, I mean so-called new spaces, to work with it. And when I went to a clean room in Dresden, I was really frustrated because it was entirely technical equipment. And they had no real spatial expressions, or nothing was actually visible. And so, because I was looking for some new ideas or new concepts of space, of course I became very interested in the biggest enemy of a clean room, in dust. That's how it started.
I just have a very quick comment. Something we were talking with Hugo earlier on. In your imaging, people tend to perceive objects in categories, and we were wondering how dust is perceived. Will it normally be associated with abstract objects or with concrete? And so, but as far as we know, no one has done this. Just something to probably think about for the future.
So we move to other areas.
Okay, an altogether different story, I guess. I'm going to try and very, very quickly explain what I am doing with dust, or what we are doing with the students at Greenwich. It's a course, it's a seminar, but it's essentially a collective research project, or at least I try to provoke them, and hopefully they respond. Architecture dust is not about rubbles, but it is really about trying to look at a possible redefinition of the fragment in architecture. So the beginning of it does not come from dust-free environments, but from a series of narratives. And to very simply begin with, from the definitions of dust. So the idea behind it is to try and dismiss the idea of dust as that which is small, but focus instead of the idea of complexity, heterogeneity, non-directionality, and discontinuity. Of course, while keeping in mind, as architects, the definition or the breaking of the architectural object and the breaking of urban space. So what I'm trying to do now is just to guide you through this dust storm of ideas we're trying to explore. It's a project which has many different beginnings. One almost inevitable for architects is Walter Benjamin. So I want to read something which I think is for our scientists. In the Arcades project, Benjamin, in one of the preliminary notes, writes, "Boredom and dust. Dream a garment one cannot turn. On the outside, the grey boredom of sleep. Sleep state, hypnotic, of the dusty figures in the Musée Grévin. Boredom is always the external surface of unconscious events." Later, when he finalizes, or, well, again, it's a dusty project, it's an unfinished project, but as he develops this note, he writes, boredom is always the external surface of unconscious events. And also, boredom is a grey fabric lined on the inside with the most lustrous and colorful of silks. In this fabric, we wrap ourselves when we dream. We are at home, then, in the arabesque of its lining, etc. It continues, but I'm just trying to draw your attention on the grey, and on the idea of this grey boredom of dust as a space, and on the fact that the grey hides or contains within it this colorful arabesque, which in itself is a structure. And then maybe we can talk about dreams and perceptions. Let's see if this works. Okay. So, we're not really interested in what is small, or we're would say more interested in what is heterogeneous, and we're trying to look at possible agglomerations or new assemblages, starting from the small, but then looking at the territory and the city. So what is matter? What is its structure? What does matter means? At the moment we are trying to define some concepts, and as usually architects do, we are borrowing largely from artists and philosophers. I'm not going through the whole story, but let's come to what interests me. So, not so much what is small, but what small means, it being relative. These are fragments of Einstein's marks on the blackboard in one of his public demonstrations of the theory of relativity, and Cornelia Parker photographs them in details. But is this small? And is this small? And is it heterogeneous, or is it compact? Or is this small? And now we encounter, or let's move on to this and this. Now, there's a problem here with the representation. These are stars. We are living in cosmic dust. We are covered by it. We breathe it. It's in us. But we call stardust the actual stars we see. This is a photograph by Thomas Roof, who very systematically, he comes from the school of the Beckers, very systematically photographs the skies and gives the coordinates of what he photographs. There are limits to this. First of all, the frame of the photograph, while the universe the photograph tries to capture is infinite. The other problem is the grain of photography. There are only so many grains of silver or whatever substance you want to use for the photography, while the image of the skies which the photograph tries to reproduce contains endless particles, endless points. Of course, there's another problem, time. We're photographing something that doesn't exist anymore. I would say that a subplot in working with dust is always time. There's the notion of something which is never still, and there's the problem of recording what and how to show it. This is just, okay, this is not a photograph, this is a lithograph by via Selmins. And here again, another problem with photography. What we call dust are actually stars, so they're not the domestic dust which reflects light, but they generate light. Now, what happens when you draw it by letting the white background of your paper show through, and you cover the rest of your sheet with graphite or whatever, is in a way probably closer to representing the universe than the photographs, in the sense that you bring the background to the front. I don't know if you're going to deal with these issues in the workshop, but I thought it might be worth considering. Then with photography, there's a lot more to be said. But again, so what is small? What is dust? And again, isn't it more about a structure or a lack of? This is the structure of protein links. This is produced by a large graph layout software. So again, is it small? Is it big? Is it a particle? What kind of space is it? And how do we visualize it or represent it when the same software is used to visualize the extension of the internet? So again, scale becomes absolutely relative, and it's more a matter of relationships. There's another sort of subplot here, which is that of discontinuity, which, yes, is important in dust. Dust is discontinuous. It's very much made of void, as space is. But what interests us with discontinuity is that we see it happening in society, in the city, in the structure of the space of the city, in the use of the city, in the use of the territory, and in the use of this territory, which, yes, is continuous, is hyper-connecting, but it is made of discontinuities. It operates on the discontinuities. If you want to go to the very, very small of bits, it's either 0 or it's 1, and there's nothing in between. So all this is about discontinuity. Another element, dust is broken. Dust is what remains of a system. And this becomes interesting because it preserves a memory of what it used to be. Now I'm bringing it to the territorial. These are drawings of the Grammatici Veteres, the scientists which define the geometrical systems for the subdivision of the territory in the Roman Empire. This is the theory with the different systems. What is interesting is that the theory in itself accounts for imperfections, for interruptions, for obstacles. And this is what happens when it is applied on the territory, on the left, when it encounters a relatively easy and flat topographical situation. On the right, what happens when the topography doesn't allow for the grid to stay orthogonal? So is this a broken system, or is it a flexible, elastic system applied onto another? Drawing, again via Selmans. This is called desert, but it is a drawing. So again, what is it we are seeing? This is graphite on paper, not sand. Another story, I'm not getting into this, but yes, dust is usually useless and formless. Useless, something which we cannot identify completely, but partially, yes. Can we reuse it? Maybe. This is Pollock. Is this dust? Does it have a structure? It also has to do with time, most famously Duchamp's accumulating dust on his big glass and being photographed by Man Ray. Is this a measure of time? Is this a system which we can codify? Duchamp made also experiments with dimensions. This is a series of details of works by Ronnie Horn, who also works through time because the pigment is sedimented in layer, the structure of the drawing is taken apart and reassembled. Is this a drawing, or is it a map of a drawing, or is it a drawing or a drawing? Does it have a composition? Another story, of course, ashes to ashes, dust to dust. But when we too long, when we work on it with language, we can make the dust language. Remove the punctuation. All the syntactical links are renegotiable. What is it? What are these words? How do they relate? I picked this because it has the word dust in it, but Weiner produces a series of these works. Memory, and we could get into Walter Benjamin endlessly long again, but let's stick to the visual. Yes, dust is broken particles, but do they preserve a memory or a partial memory of what they were? This is a photograph of fragments, not of any blanket, but the blanket which was used by Sigmund Freud on his famous analytical sofa. How many memories do these fragments have? And again, another inevitable reference, Bataille. I'm not going to give you the quote, but you probably know it. Bataille relates dust to the informe. Dust is a provocation to order, to a mathematician, to cleaners. It's something which is not noticed, but if noticed, becomes a nuisance. It is something which needs to be eliminated, but of course we know that it cannot be eliminated. So when he talks about dust, he talks about Sleeping Beauty, pointing out that when waking up, she would be covered in dust. Will she? Maybe not. If you go to the original version of the story, again, multiple origins, but the Grimm's brothers, there's no coughing and there's no dust. Because, and this is architecturally interesting, she does not fall asleep in a crystal coffin, but the whole castle falls asleep. So what happens in frozen time? Does she crystallize? Is she going to be covered with dust, or will dust become herself? Dust is something which we want to eliminate, but it becomes something we have to deal with. This is Masha Clark buying impossible pieces of microscopic real estate in New York, showing that there are leftovers also in the structure of our spaces. What are they? They cannot be built. They have no value, but they do exist. It's urban dust. He calls it zone. This is another example, another artist, much more recent, unwanted spaces due to the economic crisis in Argentina in recent years. Again, we're trying to get rid of it, and there are different containers from mythological ones. This is Danae being visited by Zeus in form of a golden dust. And yes, usually women are containers. But there's another story, and a lot of references to representation. This is a work by Jeff Kuhn. He would disagree with me. He says that vacuum cleaners are hermaphrodites and not women because of the series of functions they perform. So again, what do we do with dust? Why are we so obsessed with eliminating it? Very famous Hamilton. It is very tiny, but there is a cleaning lady on the upper left. And she is not the woman anymore. She's become the machine. She is an object. Maybe she is dust. And even Duchamp, just to go back to him, becomes woman when he deals with dust or takes on his feminine alter ego. This is another part of the story, and it is when dust breaks through systems, in this case, literally, dust cutting through fabric, which brought us to look at fold as in producing space and distance between the body and its container. And this, I'm sure you know, different possibilities of dealing with it, but also with defining other ways of making. And here we embark on a Deleuzian discourse on the smooth and the striated, which I will spare you. This is really, really, really what triggered the project. So again, not only dust, but what it is and the memory it has, but embedded in it the possible idea of a recombination into something new. I hope you've read it, because I'm moving on. And the idea of breaking orders, which means reusing things. And I'm not talking about recycling in literal term, but in looking at the structure of things at different scales. This, at the urban level, this is low-tech doing a survey of urban dust, all bits and pieces which normally we ignore or don't want to see or intentionally put in our buildings but don't even want to think about, etc. And then we really get into the architectural and the idea of the explosion, and I'm sure you know this. The idea is to look not only at the broken object of classical language, but more at this soft liquid, I would say, urban space where these broken objects float. Objects which are no longer able, even if expressed in a classical language, to reconstitute the whole, the one. Then possibility of recombinations. This is also very interesting because it has to do with layering, and then the problem opens up of time and erasure. How much is preserved and how much is eliminated in the construction of the space. And then again, more recent examples. It doesn't move anymore. It doesn't want me. You know this, explosions, yes, I'm finished. Recombinations and the idea of the archipelago. This is the continuation of the other story. So, that's it. So dust is not small, but it is discontinuous and heterogeneous. I can stop here.
Well, it was incredible. Not only cultural architectural history of reading, more or less the smallness. And I would argue, I mean, of course, because dust is small, it's so big, and because dust like disturbs and is so heterogeneous, it actually is able to create these ideas and images, and also because it does everything. It becomes a sort of metaphor for everything. And that's what I think, because I am bracketed in my research. I have this sort of list where of all the quotations in the Bible, and there is no literature where the metaphor of dust is excluded. You would find the metaphor of using dust in every literature. And that makes it so difficult because it becomes itself a meta-metaphor in a way. And in order to actually make use of the material or really apply it to architecture, I think it is good to embracket certain things. To embracket like all the meanings, no? In order to, like, for a small workshop, it's like for 3-4 days, I think it's really good to have these ideas, but also focus on something more or less. Maybe you can say something on this idea of precision, or I don't know. How is dust related to the?
Did I say precision? Did I say precision?
No, but that was my question. Could you relate to this idea of precision, even though it's totally absurd?
Precision, yeah, I find it quite terrifying. Yeah, how do you do that with dust? I don't know. I'm incredibly interested in this idea of changing, which is a big dilemma with architecture. You know, we want to move, but we don't. So we deal with objects. So we want to represent things. We photograph them, but then that's not good enough. We need to put another layer which puts distance, but in a way reappropriates the object being the sky or grain of dust or whatever. But precision, I don't know. I mean, even the most recent software, you know, what do they represent? Are they precise? What? I mean, is it a matter of correspondence of what to what? So I'm more interested in questioning it than finding it. I don't want to find it, because I think that the interesting is in this tension and how one inhabits it, whether it's representing dust or the internet or social conditions which are changing, or a broken system of architecture, because we don't know which language to use anymore. I guess, I don't know.
But I think it's very interesting because dust really is a conceptual model, no? And the moment you try to apply it, can you hear me? No, then you just take a microphone. No, I think it's very interesting because it always will stay not metaphorical model, but a conceptual model. Because the moment, I mean, you showed it, and I also tried to show it. The moment you try to represent it technically, or on film, or on whatever, its main quality is dismissed. I mean, its main physical quality.
What's its main quality? I think that's,
in my opinion, is that this 4D animation of space. It's literally exposing the time-space continuum.
But I don't think they are continuous.
No, but it's called space-time continuum.
Yeah,
because
okay.
You have 3 dimensions and the Z,
Yeah.
the unpredictable movement. And actually, it is about being not simultaneously.
Yeah, but that's exactly the problem of architecture.
Exactly.
So how do we do it? What I'm interested in, and I know that my problem is that I work metaphorically on this, right? But it is about dealing with something that instead of treating as something we want to dismiss or eliminate, we simply accept the fact that we are not. We can only move it or shift it or reorganize it. That's one thing. So let's work with it, okay, as an idea. The other thing is which I think is fascinating, is what I call the amnesiac memory of they're gonna kill me, but of dust, in the sense that, and again, I do it improperly and I do it metaphorically. It's about reusing something which is not neutral, which has a history, which has a past, and therefore has embedded certain properties which can be physical, or it doesn't matter. It's a story. It's like the Freud's blanket. Now, what that means, and I'm sorry, I'm trying to bring it into architecture, architecture in a larger sense of making space and the city and reconsidering what is space today and how we use it. It's never starting from scratch. This is essentially the post-modern situation with having to work and rework again something which is a given, but always preserves traces of something whatever which we will never reconstruct, and we don't want to, but we work with it, and it's always partial. So perfection, no, it doesn't exist.
No, it doesn't exist. I mean, even
I think it would be very interesting to move on from the architecture to habitat.
Yeah, no, both of you said that's the problem with architecture. I completely missed you on that.
Okay.
I don't know.
Because you both have
Well, I was going. If you take, let's take the term formlessness. The formlessness and the complexity of the movements on the dust. It can't be literally translated into architecture. Because I mean, this is also a question I had on formlessness. No? It stays a conceptual model. It stays an idea. It stays a perception of something, and then it's so crucial if you come to the point, if you have to have a 3D architecture, because the idea of moving whatever is actually it's what do you say, it's only has 3 dimensions to express. No? If you bracket like human beings or something. That's the sort of point, because architecture is very complex, but because we are trained to use our eyes and we are trained to actually make form in a way. So this is the contradiction also, how you introduce this highly interesting concept of complexity to make form, and at the end it becomes a form, and it shouldn't become a form.
Yeah. Well, it does. I mean,
That's
that's
the
the problem of
That's
architecture.
really the problem.
How do we deal with time? Whether you represent it in a monument or whether you work it through in animation software. When
Sorry.
do you freeze it?
Yeah, why don't you want?
But isn't that what the architectural object and the physical product of architecture is? It's kind of the detritus, the debris of this constant changing process that in itself is 4-dimensional, and it does have all of these things we're talking about, but building is what gives it that concreteness.
Exactly. Yeah.
You don't have to invest everything into that object.
No.
It's just a slice from a particular moment there, which happens to be 3D, where the actual process is not.
You know, that's become the architecture. If you,
Again, it's all relative. You know, dust moves,
Yeah.
and it's not coherent. Now we can also say that glass moves and it's liquid.
Yeah.
If you take it in the long term
Yeah.
span. Yeah? So maybe we should look at that as well.
But
I mean, then you also say, that dust for you is quite specific to this whole postmodern problem of everything that has been used before by something else, and you can't create anything new. But then you can use the biological metaphor that you constantly have new evolving out of old, and it does create something that's new and new. It's just what you picked and to talk about.
Yeah.
You also need, maybe a second.
I was just wondering, you talk about formless, but it's only in a sense formless until it settles, and then you can therefore give that a word such as dust. If you, I don't know, from my sense, metaphorically, you can only call it dust when it settles, then you have the understanding that it also mixes with the air.
Yeah.
The second thing I was interested in, if it's 4th dimension moving, because of this electrical charges, what if you ionize the air?
Well, this
If
has
so.
been done. There has been a huge development, but it's due to the size actually. The particles change their charge. So you have like 2 particles, they are plus, and the air has been. It's a special technique, but then they attract each other and they change that, and they can change their charge, so they become minus again. And this makes it so, physically it's incredible. You can use it, and if you look at the techniques, how they try to eliminate dust. Yeah.
If you were to be able to send like sort of magnetic fluxes
Yeah.
through outer space, you can then start creating streams of these particles.
Exactly. But you have so many particles who will actually change their their morphology or something. So at the end, it's not safe enough, such a method. At the end, they just filter the air all the time because it is unpredictable what the dust actually does.
Have they been able to model it mathematically?
Sort of. I don't know. Yeah, of course. It's so. It depends on what kind of dust you actually. Scientists are. It's one small remark is that the scientists don't speak of dust, but they say in plural. They say dust, and they've been very defined what kind of dust they're speaking about.
Bettina, can we move to dust from architecture as a habitat? And so Marcella can tell us something about.
Normally, it is associated with dead matter, and if you look actually more or less a bit preciser, where's the film?
I don't know where you put it.
It's Teresa.
Where is Marcella? I don't know.
It's this one. But I put it somewhere else. It's on dust mite. I put it on dust mite. Sorry.
That would make sense.
This is a film, no?
Yeah, it looks like it, yeah.
Okay.
This is it zipped. So it's here now.
Yeah. All right. Maybe some of the people are actually. So. You want to start with the film?
Yeah, or you can just put the dust mite picture as a background because it's not. Would have been useful, but I guess it doesn't. Shall I start talking maybe?
Yeah.
Okay. First of all, apologies. I don't have a lot of pictures or to show, so just to say that I'm an architect as a background, and I work at the Bartlett School of Graduate Studies. The research project is about modeling the microenvironment of dust mites in beds. As presumably most of you know, that's not me, my micro is massive.
Boah.
No, could very well be, or could be yours.
Okay, I mean, you have a small film, no? And I'm trying to open the film.
I mean,
next
yeah,
to
it's
it.
not
Okay.
important. It just shows a mite moving around. So
But that's very good.
yeah,
It's good, of course.
Okay, so what is the main aim of the research? You know that dust mites produce a substance in their feces to which some people are allergic. So it can trigger asthma, sometimes it can trigger allergic rhinitis or eczema and so on. So clearly it's something that we don't want in our environment. Also because some people can become sensitized. So if there is a lot of dust mite feces in your bed, say, and if you have certain genetic conditions, then you might become sensitized and therefore develop an allergic reaction. Now the aim of the research project is to try and predict, first of all, the hygrothermal condition in a bed, so how temperature and humidity vary within a bed, and this is a function of the conditions in the room, in the bedroom, but also a function of, say, the person who sleeps in the bed, how long does the person stays in the bed, and so on. At the same time, once we manage to model how the temperature and humidity changes in the bed, we can model how the mite population varies in the bed. So this is a multidisciplinary project. At the Bartlett, we have, sorry, no movie, so look at me. So at the Bartlett, we are mostly focusing on the modeling of the hygrothermal condition in beds, and then we have other consultants in the team, for example, in Cambridge, who are acarologists, so they do lab work on mites, So they take the mites, for example, they expose them to certain temperature and humidity, and they see if they survive, they don't survive. We also do some field work. So, for example, we've gone around in people's houses, and we put some, they look like tea bags, and there are live mites in there. So we put these tea bags, which are totally sealed with mites, on the bed under the person where the person sleeps. And we also monitor temperature and humidity underneath the person. Now the aim is we input 50 mites in. After the 6 weeks period, we know to which condition those mites were exposed. Do the mites die? Do the mites thrive? So we have to count them back. Now, this is in a nutshell what we're doing. And I was just trying to think how this whole thing fits in a way. Although the mite itself is fairly, well, it's kind of small, so it's 0.3 millimeters. Some people say you can see it with a naked eye. I can't, but you know, yes, I can't see it. But the other thing is translucent, so that's one of the reasons you don't easily see it. In terms of microenvironment, I guess we are modeling the bed, which is not such a small, piece of furniture in a way. But I was thinking that most of the talks seem to focus on space and on 3 or 4th dimension. So it's space, it's time, and so it's movement. But there are also other elements of the environment. So in my case, it's temperature and humidity, but it could also be light and, I don't know, sound, smell, whatever. So these are other elements that maybe they cannot be very, very easily integrated with architecture, but some elements like temperature and humidity, so the environmental condition in a building or whatever, are important. And what we're doing in this project is to see how the macro environment, so the room, affects the microenvironment, which is the bed and therefore the mites ultimately. But we could try and maybe look at the other way around as well.
And can you say something about the production of dust?
What do you mean by?
How are these creatures actually living?
Well, they actually feed on human scale. Yeah. So that's one of the reasons they thrive in beds, because we lose a lot of skin in beds, and therefore.
And they are producing a lot of dust.
Well, I mean, that's back to the question, what is dust? Because they are producing a lot of poo. Then now, I don't know if that's dust, but
yeah, well, that's actually, again, that's the airborne particles, so they are in the air, at the end.
Yeah, but I mean, it becomes airborne only if you sit on the bed and the particles squish, but otherwise they are quite stable.
So could you give a recipe how to actually you can't get rid of them, obviously?
Well, one of the main aim of the project is to see if we can change environmental conditions in houses mostly in order to kill the mites off. One of the reasons that these researchers started is because for energy efficiency reasons, the buildings are becoming very airtight, so very low ventilation rates. And if you have a lot of showers, say, in a very airtight dwelling, then the indoor environment becomes very moist. And mites thrives in moist environments. So one of the research questions is, are energy efficient dwellings actually, triggering the growth of dust mites? Or how can we, or how should we design and ventilate our dwellings in order to prevent the proliferation of dust mites? Now, of course, dust mites are affected by so many other things: cleaning habits, airing habits, whether you open the windows or you don't open them, how many people are there in the house, and therefore moisture production rates, and do they have readily available food. We are also making some studies on how the mites move, because it's not clear at the moment how they actually, move, or what actually drives them in their movement. Is it a random movement, and when they are uncomfortable they move more, and when they're less comfortable they stay more stable, or do they actually aim for conditions that they perceive as better conditions? So these are just thoughts, and do you have any questions?
Well, I think I quite like your idea to, I mean, not that temperature can become a dimension for architecture, but in a way, like temperature and all these technical climates do affect, obviously, the environment.
They do affect the way that you perceive the space, I think, as well. Space in, you know, inverted brackets.
And I mean, this is a typical picture used by the Hoover industry to I mean, really make you scare and show what the invisible actually is, and it horrifies you.
It does, but when you see them on the microscope, they don't look that bad. Yeah, I mean, yeah, well, not nice, but they don't look that bad. They look like little, they look like little ants, I guess. So they're not scary. But I bet when you go to bed tonight, you won't be able to sleep.
Actually, they are coexistent, and if you are not allergic to their production, then it's okay.
Yeah, but
also maybe it's even good for your system.
Well, we don't know that yet. But the other thing is, you may not be allergic now. That doesn't mean that you will never be. I mean, obviously, during childhood, I'm not saying that you will be. I'm saying that this would be more true during childhood. But you know, I mean, genetically, you may be. Some people are more prone to being allergic than others. Yeah.
I think there's also different types of sort of mattresses that don't take dust mites.
Well, I wouldn't say they don't take dust mites. This is more maybe the manufacturers
like
of.
the synthetic, you know, like for people that have asthma,
Yeah.
they have a huge range of different types of materials inside their
Yeah.
True, or is this just
In broad terms, I wouldn't say it's totally true, to be honest. I mean, of course, there are some type of fabrics and materials that can favor the growth better than others. So, you know, it depends how, you know, do they let moisture through? Do they not let moisture through? Do dust mites actually move within that type of environment better or not? But I don't think that they can prove without any doubt that that's actually the case. But some asthmatics people are advised to put, say, bed covers on their beds and then, you know, clean them regularly with wet cloth. And there is all sorts of procedures that should help reduce dust mites as well as their allergen. Okay, I have some leaflets about our research and in general research at the Pathology. So if you want my email, here or
for further information and advisory, it's super. I will definitely ask you about my
Shall we move on to the other?
Hugo Spiers, yeah? What?
Maybe I say. No?
Yeah. Please.
Because then I move away from that. Oh, Hugo, do you want to say something now?
No, I can go.
Okay.
Yeah.
Once more.
So,
I just.
okay. So,
Oh, sorry, you want me to speak?
No.
what is it?
I just tried it. Maybe. Okay.
Yes or no?
Oh,
Because I have slides.
yeah.
Oh, yeah, sorry, so I've got some slides, two, three pictures.
Okay.
Did you
No.
want- I thought it was gonna be last. You're gonna do last.
Okay. I just say a few things so to move away from the dust onto the perception as such. Yes, and very, very, very quickly. I just want to all the people who done my class color course, they know my take on color as a materiality. That's what I'm interested in. And just moving into micro dimension from another angle. So really the perceptual question. You know, the tip of the finger in this painting by Tiepolo is the color on the tip of the finger is made by all those layers of substances. And it's the reflection and diffraction of light triggered by all those substances, and within each layer you have at least 2 or 3. You know, that it creates this color. So let me just show you an example. This is Titian's Annunciation from Venice, one of the churches in Venice. And so here we zoom in onto the, well, I'm sorry, this is left to right, but anyhow, we zoom onto the Madonna's bodies, and this is the fragment. This is enlargement, 65-time enlargement of the fragment of these bodies. Then, interestingly, the same fragment under the photograph taken under UV light, and they use it. The people who the restorers and really the researchers into into paintings, they use UV light in order to identify the substances, which I find quite interesting, because what is happening is that the invisible, so the UV, penetrates the material and then gives us the information. This fragment is from the Madonna's cloak, so the dark piece of cloth with the blue shine on it, and as you can see, it is produced. The photograph on the right is taken under normal light conditions, and you can see the luminosity of the lower levels, which then penetrates and interacts with the lapis lazuli, which is on the top. This is still from the same painting, a fragment of the dark background. Again, you can see how the luminosity of this underpaint then surely optically interacts with the mixture of ochres and vermilion up there. This is a fragment taken from there is a little lectern, something Madonna is leaning on, a structure, and well, you can see there are 1, 2, 3, 4, 5, 6 to 7 layers of different mixtures of substances, which produce a particular color. On the left is a UV image taken under UV light. Now, just very quickly, just to show you this is a fragment of a painting from 14th century, but showing the vermilion. This is vermilion with gilding on it. And this is a substance which interests me greatly, because I did quite a lot of work using genuine vermilion, and it is I don't know, it's a mixture, it's a fusion of sulfur and mercury, so it's sulfide of mercury, I suppose. I don't know those technical terms, but it was regarded, it was in fact an alchemical secret in Middle Ages, because you have yellow and silver, and it comes out red. magically, something has disconnected.
The lamp's just
Oh, lamp?
no, the lamp.
Oh, in the projector, gone. Ah, okay. So I just focus on this one, because what I wanted to show you, well, just on the practical level, I, as I am a practitioner, so I work with paint. I'm a painter. And I focus on that particular material because it seemed to me that it has very particular it creates a very particular optical, well, perhaps illusion. It is something to do with space. It enlarges space, strangely. I noticed this in Pompeii. There are probably only, well, known to me 3 examples of walls or rooms painted with this material, because it's extremely expensive and also is very volatile. It can very, very easily turn black due to its very particular molecular structure. And I will not go into it because I don't know very much about those electrons and neutrons and what happens. However, I know how it happens practically because it did happen to me. And also you can observe it in Pompeii, how it happened because of heat of the lapilli falling on it. However, so there are very few examples of this, and what is what I thought might be happening really happened, and it happened in a quite amazing way, because not only this color enlarges the very small space of the foyer, the Royal Court Theatre on Sloane Square, so you can go and check it yourself, but there is a very strange optical phenomena. The color dissolves, sort of, the closer you come to it. And at the same time, and I hope I have this, no, I don't have the correct slide here, it's in the other projector. The further away you go from it, the stronger it becomes. And it's, yes, it's still visible now because there are no leaves on the trees. And if you stand on the other side of Sloane Square and look through the windows, of the theater, the color will seem extremely strong. It is something which no scientist or nobody was able to explain to me why this happens. It's a combination of that structure, molecular structure of the substance, the light which falls on it, and our optical device, which is the eye. Somewhere there, in between those 3 points, this phenomena happens. And this is just in order to make you aware that I say all this in order to make you aware of the importance of the micro dimension on the, not only on the, if you like, aesthetical level, but also there is a social and political level here. I have one quote which I would like to say because it relates to what Teresa was talking about. And I found it in the essay which Susan Sontag wrote on Walter Benjamin, on his obsession with the small. And what she observes, and I think this is very true in the larger world, if you go out there and try to talk to, well, sometimes I have to face architects or even developers or clients and convince them that, they should be using some different material on the wall because it has a different structure. Well, the minute you say it, you were ridiculed because, as Susan Sontag observes, to miniaturize means to make useless. For what it is so grotesquely reduced is, in a sense, liberated from its meaning, its tininess being the outstanding thing about it. It is both a whole that is complete and a fragment, so tiny, the wrong scale. It becomes an object of disinterested contemplation or reverie. But there is a difficulty in bringing it into, if you like, the more practical discourse. So this is what I have to say, and maybe I give it over to the scientists. So I open it up to the optical, to the perceptual now, so we can talk a little bit about that. Okay. Maybe if you are you going to step there?
I was just going to discuss.
Okay.
I thought I might mention something about color.
Okay.
Do we have a? Does this work?
Yeah.
Hello. That's slightly on, but it's not very strong enough. So it was very interesting, the idea that you could be on the other side of the square looking at a painting of Vermilion and it would look a lot brighter than if you're right up close to it. And one of the things I discovered when I was studying neuroscience as an undergraduate several years ago was the surprising fact that the retina, your eye, does not perceive color. It perceives these strange wavelengths of light. But it's only once this information reaches the brain that you actually have color. And so it's not just the wavelengths that hit your eye, it's the context of the building around the red and all the features that are arriving in your retina are on different places that affect the actual color of the redness. And so if you put different colors next to each other, it completely changes the way the brain, not the eye, represents the space that you're looking at, the colors that you're looking at. So it's very complicated. But beyond that, I'm sure there are lots of the particular phenomenon you're looking at I never heard mentioned. I think it is probably something new, the distance and the context of the actual substance is beyond where we may be in science maybe at the moment. So it's very interesting to us.
Does that mean that the particular responses can be personal to individuals, or is it?
No, that's a very good question. That again isn't often discussed, and someone who's working in medicine might know more than me to do with the changes, but I suspect it will do. You may see more red in your early life. It might change the way you see red, as opposed to someone who's seen mainly green if they lived in a jungle. This is quite possible. Very strange things go on in the brain.
How do you test if I'm seeing more red than you? I mean, I can only
absolutely.
The words, but I might say this is a very intense red, but it's different from what you think it is.
That's absolutely right. If you have to, the various. I mean, I'm not an expert on this, but I imagine you can do color matching. You can say, do these two colors are the same? But in one context, they'll be said, oh, they're completely different. In the other context, they'll say, no, they are the same, even though the exact wavelengths of light that are reaching your eye are identical in the two instances. It's the context of the other colors around it. It is very complicated.
And surely there are people who are more attuned to seeing color, like there are people who have a perfect pitch, yes, and can hear music, and so it is like this. And if you are very attuned, like I am, to seeing color, you suffer a lot because you can see terrible things quite often.
Do you think that there's also then a different balance between people? Because a lot of people feel a very strong relationship between color and space, their spatial sensibilities. I mean, do you think that also varies from person to person? So
probably up to a point. I think this level of very specialized or very highly tuned perception is very, very small. You know, that's just kind of extreme little bit, yes? But really, I think on the whole, we do generally perceive colors and spaces in a similar way. Otherwise, we would not exist as social species. I don't know. I'm not at all specialist in that. I don't know. Hugo, do you want to say something about some perceptual things or something?
I'll come on to it, I guess, when I speak briefly later about my own work, maybe, and how people are thinking about space. But I was just thinking about that point, the idea if I'm in a very small red room, it's very much like a womb in my mind, and how different colours and spaces can interact. I don't know much about the idea, but I'm sure there are, and then again, that's a cultural thing. The idea that you think, oh, this is like a womb, it's a red room, it's very small. This may not be it directly because you probably have no memory for actually being in a womb. You've been told that this is like a womb, this is a red room. I don't know.
Yeah, I think it's quite complicated because it really depends what red. I mean, I would argue depends what red and what is that substance, what is that molecular structure which reflects the light. And the same red can appear in a different light, grayish. And you know, it's very, again, a huge territory there.
Yeah, yes.
I just wanted to sort of make people aware, maybe, that those optical or perceptual things to do with space, because it's not only color but also space, are often can be traced to a micro structure. And Hugo or yeah, do you want to, Chiara? Do you want to say? Okay. I know. Yeah. Okay. Okay.
When I saw the title of this workshop, Models of the Invisible, the first thing that occurred to me is the idea of a sensory perception in the absence of an external stimulus. So I'm just going to briefly take you through the idea of visual hallucination and show you some pictures of visual hallucinations made by patients with schizophrenia and depersonalization who actually experienced these hallucinations. Did anyone? Oh, mensch. That's fine. And anyway, the idea of the absence of a stimulus can have very strong physiological consequences, and that's what I'm very interested in.
But it would be very good to show
the pictures.
Because you can't.
Yeah.
No. Okay. We're starting. Oh, we are sorry for these technical delays and for this marathon, but maybe you can just say that the workshop actually will start tomorrow at 5, and we are meeting in Tottenham Court, so
on the second floor.
On the second floor in Tottenham Court Road Studio. So just some more technical organizational information. But I think my computer has given up somehow. Oder?
Oh, that's fine.
Okay, it's this one.
Oh,
it's okay. Someone has no electricity, so it stopped. Okay.
No light bulb.
Scheiße, that will take time.
I can talk without.
Yeah, just
Yeah.
5 minutes.
Yeah. So what I wanted to show you is the results of some studies that use magnetic resonance imaging, and they took images of the brain of people experiencing visual hallucinations. What is quite interesting is that the content of the hallucination seems to activate specific areas of the brain which are normally activated when people with no hallucination actually view real objects. And I wanted to take the case of two conditions. One is it's called the Charles Bonnet syndrome, and it's when people who are physiologically unimpaired experience visual hallucination, but they're blind or they're partially sighted. And the second example was the example of schizophrenia. Yes. So I just go through the normal, yeah. Okay. So this picture is called The Maze, and it was painted in the late 50s by a then patient of the Royal Bethlehem Hospital called William Curelex. This is, as you can see, it's a depiction of a visual hallucination, and it's extremely detailed. The artist himself describes what the different scenes are, and let me see if I can point. No. Anyway, the picture in the middle, where there is a white mouse curled on itself, represents him, and the idea is that he's stuck in this maze and is unable to act or escape. This picture is not so clear, but for instance, the picture in the middle at the bottom represents a test tube where the patient is trapped, and all the people around are the psychiatrists who were treating him at the time. You can recognize them if you see the picture of them. So this is just an example. Another one is this. This is the work by another artist with schizophrenia called Andrew Pushkin, and again he was trying to draw. This is a sort of digital art, the content of his hallucination. And I don't know if you can recognize it, but the brain is on this surface. It's actually outside the head. And I think in the head is replaced with something like, it looks like a plant or a cactus. Another one is Paul Lake, again another artist with schizophrenia. And it's, again, this idea of being trapped and very, very clear, this cobweb and this inability of coming out of it. So I just want to say that these are hallucinations as opposed to illusions, because hallucinations occur in the absence of an external stimulus, whereas illusions is when an individual perceives but misinterprets an object in reality. So what I wanted to show you very quickly is this is an MRI scanner, which is a non-invasive technique that works on the principle of magnetic fields and radio pulses. But without going into detail, this is, I already described to you what this Charles Bonnet syndrome is. This is a study conducted by Al Sandhaus in 2000, and what basically shows, they scanned patients with Charles Bonnet while they were hallucinating, and then they asked them to describe in detail the content of their hallucinations. They categorized this content into three main groups. One was people who were hallucinating landscapes and objects. Others were hallucinating people's faces, normally threatening faces with grinning teeth and evil eyes and so on. and then people who kept seeing exactly the same object, the perseveration of hallucination. These areas, so the red areas were activated when people hallucinated objects and landscapes. But the same areas has also been found to be activated in control subjects when they actually viewed landscapes and objects. So they're exactly the same areas. And so is the green one for faces, and so is the yellow one for this perseveration. So what I'm trying to say is, for these patients, their absence of an external stimulus didn't prevent them from experiencing exactly what a normal, unimpaired person would experience. Yeah. Yeah. Yes, they've done this kind of experiments. So they compared these three conditions. The first one was to view a real landscape. The second one, it was to ask a person, an unimpaired person, to imagine a landscape. And then they compared people who were hallucinating a landscape. And as you say, if you imagine an object, there seems to be an indication that specific areas of the brain are activated. So if you imagine a landscape, you would activate these areas, but not to this extent. So there is some, but it seems that for these particular patient groups, the vividness of their experience equals the reality.
Has this syndrome been known in some form or other to occur in people who've never had some? Any even partial?
I'm not actually 100% sure, but I think so. It's it's not very common, but it occurs when people, in blind people. And I think that the peculiarity of this syndrome is that people are aware of experiencing hallucinations. So there isn't this non-distinguishable sort of line between reality and hallucination that you find in schizophrenia. These are people who are completely aware, and they know that what they're experiencing is not real. So, and just very briefly, the case of schizophrenia. This is again a study when people with schizophrenia experienced somatic and verbal hallucination. One thing that is very important to clarify is that in this patient group, there is no insight into their hallucination, or not so much. So they hallucinate, but they're not always aware that they are doing so. Sometimes they think that what they hallucinate, they're actually experiencing. But again, what is interesting is that the areas activated during the somatic hallucinations were the same. They were activated during tactile experiences in controls, and the verbal hallucinations as well. These particular areas of the brain are activated when controls hear speech. So it's speech processing areas. So that's really open to debate. Why are these people experiencing these hallucinations? One idea is that perhaps it's evidence taken from people who have been sensorily deprived, or people who have been confined in a small space for a long period of time. In the absence of external real input, they start hallucinating. So one of the ideas is that if we were sensory deprived, we would all hallucinate, and reality is what prevents us from doing so. There are many other theories about neurotransmitters and so on that I won't go into. Let's see if you have any questions. It's more sort of open for trying to get stimulate some thinking. And
very interesting is that, I mean, your research on
Yes,
and
yeah.
not on measurements and
Yeah.
not on any other, I don't know, chemical, chemical, I don't know, decisions or descriptions.
Yes, that's right. It's based on a system of coordinates.
Yeah.
And that's what we were talking earlier on, and it's you have X, Y, and Z coordinates, and that's how you define the space. But what I also thinking is that sometimes I was thinking in terms of, in this context, in terms of architecture, sometimes it is important what the reality, the kind of emotion that the reality triggers, but it's also what is non-real. So you can have extreme physiological reactions in the absence of any stimulus. So it's most what a context makes you think of, rather than the context itself. But there was.
What I also was very, it's interesting, the first images you showed, but hallucinations and these drawings, that they actually, I mean, it's not a virtual reality they are showing or
No.
they are presenting, but it became very simple. I mean, all the parts became a symbol for something. They're standing for something.
Yeah.
So yeah.
And it's the artists themselves. They describe, particularly this Kurelek. He wrote his own biography, and he describes in detail this particular drawing, and it's quite amazing. Every little square or partition evokes childhood or family or his political involvement, and it's.
So it's the opposition of some sort of abstraction. No?
Yeah.
I mean, it's the opposition of a concept.
Mm.
It's really sort of symbolized representation of their
What they, yeah.
experience.
Mm.
A different issue. You mentioned earlier there's a syndrome called Lapuccian syndrome, where you could describe this idea of people who have a syndrome, they believe that they've become incredibly small or big.
Yes, yes. Well, this is it's a type of hallucination which is quite commonly experienced by patients with schizophrenia, and they think they're very, very small, and they live inside their own organs. So they think they live inside their veins, and all of reality becomes a tiny micro reality that is physically experienced because it's inside themselves.
It's like Gulliver's,
Yeah,
Gulliver's
yeah.
Travel.
Yeah, that's why it's called.
One thing, but just a continuation. The first drawings, they are of course informed by memories and cultural context, and the nature of the pathology and the technical skills of the patient and artist. But I found it quite interesting how they represent space, because this one is a taxonomy, and there's this, I don't know how it is part of certain conventions and skills, or how much it is part of the pathology, this need to put order into these things, which presumably are not so ordered, or maybe they are more than we think they might be. Now, if you move to the next one, the things become blurred. I think it might be a windowsill, or it might be a table, or it might be a French window, but we don't quite know. There's this reflecting thing. Is it a mirror? Is it some metal frame? Whatever. If you move on, there's this Baconian definition of perspectival illusion, but it's probably an endless, bottomless
Like a
space.
pit, yeah.
So, how are these space visualized? Okay, in different ways, but are they seen in different ways? I don't know. When I hope I'm healthy, but when I dream, I see spaces which I could not inhabit with my body, or I could not draw. Maybe I could suggest to you as my therapist
Yeah.
computer animation, maybe. So how much is it the translation from the vision or hallucination or illusion into the representation influenced by cultural elements, and how much do they differ between the different patients? Do you
Yes,
know that?
it's very idiosyncratic experience, because as you can see, these three, they're very, very different from one another. And I would tend to say that only the very organized patients and the very high functioning patients are actually able to put on paper or on canvas what they can experience. I think probably the very disorganized hallucinations are the ones that we will never learn about, because patients are not able to communicate, let alone show them to us.
Have there been experiments with, I don't know, photomontages or film or attempts to reconstruct this? I mean, in cinema there are.
Yeah.
They show you that somebody hallucinates, they try to simulate colors or blurring,
Yeah.
etc. But have there been scientific experiments in that direction?
Yes, I've just come across one a couple of days ago about reconstructing hallucination through virtual reality. And the idea was to show this hallucination to people without a history of schizophrenia and see whether, in terms of neuronal activation, they would have the same responses as patients, and they don't. It does the same thing that I was saying earlier on about imagining something, which is not as strong as experiencing something as an hallucination. So, yeah, there is a little element of it, but it's not, the hallucination cannot be fully explained because it's very, very strong and it's not comparable to the, let's say, fake experience of an hallucination.
Do you measure also not only how the brain reacts, but also the body, I don't know, muscular tension or sweating or...
I don't, but maybe you.
People do.
Yeah.
That's why maybe we should be worrying about these things. I think it's very interesting to find out.
What's the difference between this and Greenwich?
Well, I think physiologically there is a difference because your autonomic nervous system works in a different level. But especially in the case of schizophrenia, there is no distinction between the hallucinatory state and the non-hallucinatory state. So when you ask them, for instance, what have they done in the afternoon, they would say they were in a cobweb, because they actually don't know, whereas we know that when we dream and when we wake, the dream is ended, even though it can be relevant. But that's the ability to distinguish between the two.
What is imagination? How would you...
Antonio.
What I understand of schizophrenia is the only single mental disease that every single race across worldwide experiences, which must mean that it had developed at some point before we split apart. It also doesn't seem coincidental that majority of the Nobel Prize winners are actually schizophrenic. So it's like asking a question of, is it this idea of imagination, or this perverse imagination, is what seems to me to be the driving force of the human civilization, and in a sense it's nothing more than a more less diffused altered reality.
Yes, well, I personally believe in mental illness as a continuum. And especially these days, people are not normally admitted unless they seek help. So the majority of people who are in hospital, who are in psychiatric hospitals, are self-referred because they feel unwell and they're actually personally seeking some help. So I would say, yes, it can be an extreme form of manifestation of imagination, which can be seen in a positive way. But if the person themselves, if they perceive that becomes a problem, or if they feel in danger, then maybe it is something that should be looked.
Perhaps it's not. It's in a way their inability to express it into something constructive.
Yeah.
And in a sense, this is why many of them begin to do art and some kind of expressive form of their imagination.
Yeah, yeah, absolutely. And I think the main purpose of psychiatric hospitals these days is to make people well enough so that they can say, I don't want to be here anymore, when they're ready.
Is it then their actual illness, or is it the environment that they're surrounded by telling them that the way they are thinking is in fact an illness, when maybe it is not an illness, and it's the suppressive forces of this social order
Yeah.
which causes this and brings us about?
Yes, it could be.
Yeah, it's the social orders that
Yeah.
Is that social, that's about social constructs and whether or not the behaviour produced by schizophrenia is acceptable within a particular social
Yeah,
context.
yeah.
So
Yeah.
for me it's a kind of scale.
Yeah.
But I had a question about the way hallucinations affect one's experience of real space. And is there any research into that? So, for example, is hallucination experience as a kind of layering of real and unreal spaces, and are people aware of the kind of boundaries, if you like? So, for example, if I'm hallucinating and thinking I can hear a voice down the road, that's a kind of spatial experience. And I was just wondering if there's any research into some spatial distortions.
Yeah. Well, unfortunately, it's one of the most common ways that people end up committing suicide, because they hear something or they see something outside the window and they don't have a concept that it's the window, and they will damage themselves if they go out of it, and they often do. So, yeah, there's no, the space, the sense of space is completely, it becomes completely subjective.
You mentioned a while ago that when we were chatting that if you experience sensory deprivation, you start to form hallucinations.
Yes.
And I was wondering, given what we were just discussing about the impact of schizophrenia and hallucinations might drive you to be more creative, should architects think about creating spaces in which we can hallucinate?
This
drug, then
it becomes a drug.
Yes.
But if you don't know what is the mechanism for hallucinating, how can you create a space that triggers hallucination?
Well, I'm wondering, imagining a white cube with nothing else in it. And there are those sensory deprivation tanks people go into to do that, but in terms of building offices and houses and places where people might go to be stimulated, I don't know whether there's a drive in architecture.
So maybe I'm still okay for the last.
Yeah, I'll be very quick. I'll be very quick.
So,
Yeah, I'll be very quick. Yeah, that'll be mine. Okay. Do we have a... okay. Okay.
If it's this one, yeah.
Okay.
It's,
Is that it? And then I've got this little mouse. Oh, and that can move, great. Okay. I'm just moving through these pictures to get... I'm going to go to... this is where I'm going to start if it doesn't leap on. So I'm a scientist working 2 squares away in Queen Square. I'm going to come back out and go back in. Okay. Okay, here we are. So maybe I'll just stick with this slide. And I study the brain, a particular bit of the brain, which will appear in a moment, called the hippocampus. And the reason I'm interested in this bit of the brain is that it deals with space. As far as we understand, it processes space. And not just little spaces in front of us whole worlds, whole cities are represented in these micro spaces within our heads. In each of our heads today, hopefully, unless we've got some neurological problem, are these thousands of millions of cells all dotted throughout your brain. Unfortunately, I couldn't get a scale for these pictures, but I think this is approximately about 1 millimeter in size, this space here. So these are incredibly small spaces. And I'm interested in how the brain represents space, stores space, and processes space for imagination, for moving through space, allowing us to find our way around. And the way I became interested in space was finding out, I'll have to come out again, I think. Here we are. Was through some discoveries made back in the late 60s here in London, a few squares away, up over in Gower Street. Now this is a picture of the hippocampus, which is this bit of the brain I'm particularly interested in because we believe it processes space and when it appears. What I've got here, I was hoping to have a video of this to help explain what this is showing. Essentially, you can record from cells in the brain. In humans now, patients who are undergoing epileptic surgery often have electrodes implanted in their brains, which allow us to identify where the epilepsy is coming from, so that they can later be surgically removed. Whilst this process is going on, it's possible to record from cells in various bits of the brain. Now, it turns out various cells do all sorts of different things like perceiving colour. One of the cells that's been discovered in the early 70s were cells that are now known as place cells. And these are cells that represent local space. Now, what's shown here, if I can get this mouse to move, this is the tracks of somebody or an animal, somebody moving around in a cubic space, like this space here we're sitting in. Now, it turns out for these cells, they only operate, they become active, they're processing information only when the person is in a particular region of the space. And it doesn't matter whether the person moves in through it from the west or the east or the south or north. Whenever they're in this particularly this bit of space, the cell will be more active. Now, this seems like a very strange phenomenon. So why would the brain have these little cells that respond when you're in a particular place? You can imagine if you had enough of those cells, you could slowly represent all the spaces we've ever been to and represent places we might be able to go to in the future. And this is an idea that was encapsulated in the late 70s by some scientists at UCL. And people have been studying this region of the brain, the hippocampus, ever since this time, trying to understand exactly how these cells operate to allow us to find our way through spaces. And what I've been working on in particular is looking at how they're engaged when you're actually finding your way around, when you're going to new places, when you have to integrate information about space. And so, like our previous speaker, I use magnetic resonance brain imaging. So here's an actual physical scanner. The person lies on a bed and they enter into this scanner, which allows us to, using large magnetic fields and radio frequencies, harmless like listening to a radio, non-invasively allow us to look inside the human brain and create images down to a millimeter scale of what's going on at any particular moment in your brain or a particular person's brain. I'll try and get this. So here is a slice through a brain. You've been seeing brain images in the last talk. I've been looking in particular at this brain region that I've been showing you the slide before. This is the human brain. This is the hippocampus. And what this little region here shows is a region where there was more oxygen used by this particular subject. Now, what we've been doing, why we've been looking at space, it's very hard to understand how people navigate when they're stuck inside this huge tube of metal. And the only way we've been able to get around this is to use virtual spaces, spaces that don't actually exist, where we can project into the scanner and allow people, healthy people, to find their way around. So what I've drawn here is, this is an image from one of these environments. So they can be quite detailed, and subjects essentially often shown a picture of a place that they have to get to, and then they have to move through this virtual world until they get to the place they're looking for. So here's a map at the top, so the subject might navigate whilst being scanned through this various environment to various places. And then we can look at which bits of the brain are engaged specifically when you're trying to find your way around. And it turns out that this region which has these cells which respond when you're in particular places is more active when you're actually finding your way around these different environments. And so this is the type of research I'm doing. And I'm, through looking at this, I'm very interested in how the brain, how tiny bits of the brain, as we saw in the last few slides, these microspaces inside the brain, these ones here, how these particular tiny cells, where I mean, this is the lower level of dust, where these cells can represent large spaces, such as the whole city of London can be represented inside these cells. I'm currently studying taxi drivers to look at how they represent a whole city and how it might be stored inside these cells. And there's been some evidence from our group in University College London that these cells can grow, that there can be increases in these microspaces. The longer and the extensive experience that these taxi drivers in London take on, the longer they navigate around London, the larger these particular bits of the brain can grow. And so that people who have been driving in a taxi for all 40 years have a significantly larger, or we can't quite tell, the resolution of our imaging techniques is not capable to tell us whether these little cells are growing, whether we've got more cells there, whether these little connections are increasing. And we're trying to investigate this at that micro level, how these tiny connections can code large spaces. Now, one of the few interesting things, that's basically what I've come to talk about, but in linking up to the previous talks, I've become aware, just listening today, how, for example, when we look at these strange images, as in the previous talks, of these strange, what look like, somebody used the word landscapes earlier, at the dust level, we can look down an electron microscope, and we can see an image that's produced, and we can now even navigate through these virtual images. It's possible that the cells in our brain will start to learn these landmarks and represent these micro worlds as if they were real worlds. And what does this mean? This is just something I've just been thinking of this evening. What would it mean to be representing this micro level? And it all comes down to the way we as humans perceive a three-dimensional world around us at a fixed level. We project that onto the world we see out there, a model of that. And that's certainly my belief. And we represent it at this level. So it does, as we start to acquire more and more images and experience and look at the micro-level world, we're going to get used to, our brains are going to have to get used to navigating in these strange worlds. However, the limits of that in terms of 3 dimensions, as we've heard, is going to limit us. If we're going to have to think about the deeper and the deeper and the deeper the space, as we go down deeper into space, it becomes more and more curved. I'm not a mathematician. I've been interested in maths as I've been involved in this studying space. I've had to think more and more about what do we mean by space. And apparently the further and the more you go deeper and deeper, smaller and smaller in space, the more curved it can become. And so that the actual movements across space become very distorted. And at that level, I think this system we use for finding our way around will break down, and we won't be able to understand how to move around these spaces because it doesn't apply to our everyday experience. So there are real issues there. And also, obviously, there's this micro level inside the brain. How is that affected by various phenomena? We've been talking about the optics of light and how the different chemical quantities of different things can impact on these particular cells in our brain can respond to different perceptual bits of information. And the other thing, just to finish on this very brief ramble, if I go back up to my brain imaging slide, is to say that one of the problems of looking at virtual reality environments, I've personally found, is we're trying to recreate the real world inside this static scanner to try and allow people to look at people normally navigating around. And of course, it's not particularly real. And one of the main reasons it doesn't look very real is there's no dust. There's no dirt. And so one of the things people are probably trying to do to develop these virtual realities to make them more real is to include dirt and dust. But how you do that and how you put that in there is vastly mathematically complicated, and you need incredibly powerful computers to do that. So I think that is becoming, and certainly the computer simulations I've been using of London, they have started to put dirt and dust, but it's not as detailed as I think we need. London certainly is a very dirty, dusty city. But that's basically, I just want to introduce the idea that there are cells in your brain as you walk out of this building, as you move through the building out up to the bar. There's probably a lot of cells representing the bar up there. The more familiar you are with space, the more distinct they'll become. And there are people looking at how different landmarks can change these, how smell can affect these cells, and how in this brain imaging, how all sorts of different cues can be integrated to process space. So if there's any questions, I guess that's just my ramble now to look at space and how we look at it. But I don't know, are any of you familiar with this idea that we carry around cells that represent spaces? Because it's an interesting thing, because I particularly look at the architectural world. That's what the level I'm interested in, how we represent cities, how we find our way from one bit of a city to another. And it's very hard to do that. But it's only really at that level, if I go into that previous slide, that first one. It's only at this large level. I mean, this could be the size of this sort of area here. And of course, it begs this question. As I had a video I was hoping to show you, as an animal moves through, these cells at particular points can become active and then decrease in their activity. Question becomes, if I'm a human, how big would these cells, how large an area would these cells encode or respond to? Because if I'm a small animal, like an ant, I probably wouldn't have this apparatus in my brain, but a very small animal, such as a mouse, would have a very different perspective on the world. And its physiology would mean that it encodes space at a small level. But there's probably a limit to that level which the brain can process smaller and smaller spaces. So I think people aren't asking that question, actually. That is not something that scientists are... I never heard anyone ask the question before, what is the resolution that these cells can respond to? Is it a meter? Is it 2? Nobody knows. And the other funny thing, I think, if I should mention, that I became surprised when I was an undergraduate learning about these things, is that these cells all lie in this region, the hippocampus, in the human brain and any mammal, and the ones next to each other do not represent spaces next to each other. It's completely random. There's no link, there's no reason why this cell here should be next to this one here in terms of its topological relations. And you might think, why? Given that these things might encode small, say, meter by meter spaces, if you had to put all those spaces you've ever been to, meter by meter, into your brain, you'd run out of space. So what we think happens is that various combinations of cells work together to code all the different bits of space. And so you can build up this unified representation of space by using lots of different bits of the brain. So it's bizarre. It's one of the few things where it's not related. The space out there in the external world is not related to the locations of the different cells in your brain. Because certainly for vision, as we see the world out there, the way we'll see the entire front of space ends up in an exact map on the back of your brain. The colors, the spaces you'll see would end up being processed by exact bits next to each other. But it's not so for large city-type architectural space. So there's some very strange bits of phenomena going on inside the brain that we're only just beginning to unravel. So I should stop rambling through this and let you ask questions. Yes?
Don't stop.
No.
Extremely fascinating. We are now producing a lot of images we did not know before, whether they are incredible enlargements of the very small or the making visible of the invisible. You're telling us that we are developing new cells, or we are changing ourselves in how we perceive them. So in a way, we become able to see more, better, different, how?
That's a very good question. I think that is an interesting idea, the way the brain, as if you imagine, some of the pictures you showed were very interesting about, you can imagine looking at chalk on a whiteboard and how the brain would see that as a small space. But if it now imagines it's a whole galaxy, dots, the way the brain would represent that would suddenly change as far as we understand it. There would be a switch. Some different bits of the brain would become engaged if it imagines it's a relationship between lots of distant objects. But your question's about when we start to use images more and more, we now deal every day, for example, with electron microscope pictures. Will the brain change to deal with this? And I don't think it's got the capacity. I don't think it's something it evolved to do. So we're trying to drive it to, certainly in dealing with 4 dimensions. Nobody, as far as I know, can think about 4 spatial dimensions. It's not possible, as far as I know. They claim to. They claim to, but I'd like it just. Yes, that's it. But
we were talking.
Sorry, why is it so? This is an open-ended question. Why is it so difficult to process that extra parameter
Oh, well, I mean, actually imagining that there were four, that you could move from a cube, another spatial dimension.
Right.
And that's what I mean. When you go, actually, there's a few more slides. I did have a. If you imagine a curved space here, so this is what mathematicians constantly look at, and they say, "Oh, I'm interested in how space is represented." They think about the idea that you're moving on a surface, and you're completely unaware of the curvature of this space. You can't see. For you on this flat space, if you're living in 2 dimensions, you're unaware that it dips down and comes back up. So it'll take you a long time to go down this hole and come back up. But perceptually, you will see no difference between it. And so it's that extent how the brain can process this type of space, I think, is limited to three dimensions. It's not physically possible. I could be wrong. It's just my speculation that we've evolved to live on a flat plane. And not that we represent 2 dimensions, but we live on a flat plane with 3 dimensions. We don't live in a 4-dimensional universe at that level.
For example, a bird or an airplane, they perceive space in 4 dimensions because they have the.
In terms of.
Not living on a plane, so they have the 4th dimension.
Well, that's an interesting point. Yeah, I mean, as in, they have a. We have more like a 2-dimensional. They have a 3rd one that they use more, I'd say, yeah. And they may well use bits of their brain quite differently. I would suspect so. Certainly they have a sense of a magnetic sense that we, as far as we know, lack. We don't have that sense. Before I forget to mention, there is another strange phenomenon which I don't have a slide for, that I think is quite interesting, that I discovered a few years ago. And that's some work that anthropologists have been doing, traveling around different tribes around all sorts of languages of the world, looking at how people represent space in different cultures. And they found it varies enormously, that the way people talk about space can be very different. And so we were just fiddling around with this idea of dimensions, and that there's one of the key aspects of space is reference frames. The idea that you can have a reference frame, you can represent physical things out there in the world relative to me, to myself. I can see that it's on my right and it's over there in that direction from me. Whereas I can imagine you can relate things between those 2 chairs. It could be halfway between those 2 chairs. Now that second one is an allocentric, non-centered reference frame. There are some cultures where they lack the use of language to describe things in the world in terms of an egocentric framework, which is very strange. These people, for example, live on a large hill in Mexico. There's a particular language-speaking group, and they represent the whole world spatially in terms of uphill and downhill and across hill. And so if they're having dinner and they're asked to pass the salt over the table, they will literally say, "Could you pass the north salt to me?" rather than say, "Could you pass the one on the left?" And the strange conclusion, they've tried things like showing them mirror images of pictures to say, "Can you describe this?" And they will describe them in mirror images as the identical description in language. And indeed, when asked to do all sorts of basic perceptual tasks, they'll always do them with reference to the external world. So these people live in this world of a real north, south, east, and west. Whereas if you speak English, you don't normally worry about this. You don't normally tell people to go down this alley, go south, then go west, then get up the stairs, and then go east again, and then go west. You wouldn't normally, in English, it would make no sense. So and the way that impacts on the way we think about the world is huge. I don't know whether architects, where when you think about building a building, the way it might lie on the slope for these people would be culturally huge significance. So there's some very strange things in space that people are looking at. But people are waiting to try and get these people into one of these MRI scanners to look at how they think when they're thinking about these relationships. It'd be quite interesting to see which bits of their brain are more active. Yeah. I don't know.
There was one point which we talked about earlier, which maybe relates to language, and that with those techniques of magnification, there is a point, and this was somehow to me visible in Bettina's sequence of images, where it somehow stops making sense to us in terms of imaginary I mean, there is a level,
Yes.
of magnification of dust where you still feel it is dust. Although we cannot see it, but we feel that material or that substance. And there is a point where it breaks. It becomes something else. It becomes completely surreal scenario. Because perhaps, I don't know, maybe this is to do with language or how we actually
relate to scale.
To scale, I don't know. There seems to be that point.
It's interesting what you said about the hallucination that you have, you are becoming yourself a micro cell or very, very small. And because you couldn't relate to these pictures with your own body, you couldn't become Gorillas or something in this micro world.
But maybe, Antonio, this is something to do with the ability to place even dust that is perceivable, but it's not probably seen in context. So as long as you can imagine the context, then it's real. When it loses its context, then...
That's right.
Do you understand space? There was some guy called Hugo Spiers, 14th century, I don't know if you know. It's who spoke of space, understanding what space is, but imagining yourself moving within it, or imagining yourself moving through it. And it comes to my idea of this sort of redundancy of space where, let's say, you're at the bottom of the stairs and you're walking up the stairs. Between the bottom and the top of the stairs, there's redundant space. If it's the first time you move up, you experience it, after which it becomes routine, and then that space becomes redundant, and in a sense, you don't take in the information anymore.
I'll show you a quick slide. I didn't include this one actually, but we have been looking at that, almost that phenomenon, at a scientific level. Phenomenally, it's quite interesting. Phenomenologically, the experience for me of going to work, I just constantly follow this redundant route. I don't need to process it or think about it in the same way. I don't have to worry about it. In this slide, so this was a study that I was involved in, where we were interested in people finding their way around how, if you're asked to find that coffee shop in Soho you know exists, you haven't been there in a very long time, and you have to try and think how you're going to get there. The spaces you pass through are probably less redundant. You're having to access them, think about them, use them. What we got people to do was exactly that, and we compared it to a condition in the brain where people were just following the same boring route again and again and again. And they're phenomenally, if you look at the actual what they're seeing, you couldn't tell, looking at what they were seeing from the screen particularly, that was the case. Because we keep interleaving the two experiences. However, the brain activity is very different. Your brain is much more active in using this particular hippocampus region to process those new, trying to find that coffee shop. But when you're just trying to follow that same boring route to work essentially every morning, then you use a very different bit of your brain, a brain that you use for just habit learning habits and things, what you need to do repetitively in the world. So it does change. It's certainly inside the brain, that concept of redundancy of space. But I guess the brain is always processing what seemed like that bit in the stairs halfway up. But you learn to neglect it because it's not useful for your brain to be spending its energy worrying about that bit of space, I think.
Is it the fact that are you actually within that space, or you actually progress within that direction, within that time, that dimension? You are not actually currently in that midpoint of stairs. Are you actually there, or are you actually at the top of the stairs? And that's what I mean by the fact that it's like you have a desire of a movement or a destination, and that becomes your orientation of the space. And it maybe is that when you talk about the cells within that room, is it only at that point reaching it?
That's really nice.
Is it that when that cell becomes activated?
That's a very interesting question, actually. That's one of the real problems, actually, in the whole scientific field, because if you think about those cells, I'll just go back to the picture again. These cells only encode where the person might be at any time. So if you just had a set of cells that told you where you are now, that's useful for telling you where you are, but if you want to go somewhere else, how would you do it? You couldn't actually do it with these cells. What's been argued is that you need what would be described as goal cells, cells that are active, informing you where something will be in the future within this map. And people are searching like crazy through the brain to find these things, and they haven't yet found them.
Is it actually a goal cell, or is it just the fact that I think you have this idea or a template of space? So I think it was Plato said you got what is a chair, and you imagine a chair by a template of what a chair is.
Yes.
So is it the application of templates to spatial features, which then you can then assume that and then understand it in correlation to your incoming input as well as your imagination and the spatial within the mind space?
That's quite true. I don't think we're even there yet. I think the idea that we apply a template is certainly true. There's certain properties of these cells which make you think at least the brain is not naive. It has pre-programmed to apply a map to the world. The resolution of these cells, how well they're spaced, is particularly regular, and so it implies there is something there, a prior sort of Platonic system, like something that's set up in advance. It's an ideal, what it's looking for, and I guess that asks the question in architecture how we build these spaces. Why is it we've chosen to make certain spaces as they are? Is it there's something about the way this template exists that we want to do that?
Question on this.
Yeah.
I'm quite interested in what this template is, because I'm interested in maps. Mapping.
Me too.
What are they, or what are they becoming? So maybe you have an answer for me.
Oh yeah.
Story.
No, sir.
I used to live in Venice.
Uh-huh.
I go back. I'm in an area I know very well. I need to go from A to B. Both A and B are familiar. I know how to go there. I panic because oh my gosh, how do I go there? I don't remember. Get the city map, and I think I'm stupid. What are you doing? Put the map away. You don't need the map. Just go.
Yes.
So I switch off whatever template or map I had in my mind.
Yes.
Because at that moment it just didn't work, and I navigate from A to B successfully, following another template which had a lot to do probably with memory, with the haptic, with smells, with the texture of the walls, with the locations of my favorite shop. I don't know. So I obviously have binned my mental map, but not only the paper one, but I have used another one, presumably different cells. What have I done?
Oh, that's an interesting question. I've never heard. This is what's so useful when it comes to these sort of meetings. Is nobody ever asks that question. But essentially, these are the sort of problems dealing with humans, trying to understand how the human brain works. It's very complicated, and people are interested in the idea that there's map-like survey representations of the brain, that you can learn a survey view, this map-like. You can imagine looking down on Venice. You've even seen pictures, probably when you first moved to Venice. You had to get this map out a lot and look at pictures of it. And that's quite a different representation to the kind of route-based memory you would have interacted with, to do with looking just your brain processing those different landmarks, textures of walls. So there is an idea that there are two different types of system, and people are currently trying to pull those apart and see how they're related and how they work. And I think the question of what these cells are doing is very problematic. Are they representing these maps? Given that they're so biological that every animal, mammalian brain has these cells, why would they deal with visual maps? It doesn't make sense. It's probably more, that visual map thing is not to do with these cells. It's more to do with those sort of, that abstracted route knowledge of how you can get from any bit of Venice to another, how you can recognize all these landmarks as you go, and take shortcuts through it. That you might, and that's one of the fundamental principles in this idea, that you need to be able to take shortcuts in life. And the only way you can take shortcuts is if you've represented the space properly, not just this goes to this to this, that to that. You need to actually know the space in a reference frame. So there's ideas like that people are very interested in.
I would like to ask you whether there's any difference between men and women.
That's a good one. There have been studies, very inconclusive, Certainly, there's like a folk idea that men are better at space than women, and apparently that isn't necessarily true. Certainly, finding your way around, men and women are better, are just as good as each other. Certain studies showed that the women tend to engage different bits of their brain to men in these sort of brain imaging tasks when they do these things. What we do know from studies is that men use distances and angles more than women when they're thinking about finding their way around. They'll say, oh yeah, mate, it's just 100 yards down that way, more often, or they'll use that type of information. Women use landmarks a lot more than men, such as shops, for example. It might be an instance. So I know friends who can tell me every little shop on Oxford Street in absolute detail. So there is some, but by all means, whenever you look at the difference between men and women, there's always a huge overlap in the same way that men and women's height varies. But I think in space there's lots of different things, and certainly navigating, I don't think women tend to be significantly worse or better than men.
But ask you something else, also a brief technical question. I had a photographic memory for maths, virtually 100%, until I got a bang on the head. It went. Is there can you think of any reason why there might be a physiological reason for that?
That's not something I've ever looked at. That's quite interesting. Perhaps you should come by and take part in the study. But no, I don't know what the situation. I do remember meeting a patient when I was doing my PhD who had this surgery for epilepsy, and he told me that he used to, before this brain operation, he used to be able to imagine all sorts of things. You know, he could just picture up, imagine mountains and things. After they removed the epileptic tissue, done this brain surgery, he couldn't imagine anything anymore. He'd lost the ability to imagine the world, and he was really pissed off. He couldn't. It was so frustrating for him.
I could remember details of maths for 5 or 10 years of foreign cities, and it went completely.
Wow.
I was knocked into the gutter in high hope.
Yeah, must be annoying. Yeah.
On that image, you have one cell that kind of
Yeah.
when it's in the sense.
Yes.
Do you guys know whether those particular cells are linked to the actual space itself or to what encloses the space, the objects? I mean, you talk about landmarks.
Yep. That's. Is it just the?
Between a matrix of objects, or is it the space itself?
That's a very good question. It's the kind of question that people ask. Well, they don't. In my opinion, they don't ask enough. This is a very good question. What we do know, and I didn't think it was worth bringing along. Perhaps in retrospect, I should have brought all sorts of extra slides. What we do know about these cells is that the geometry of the environment has a huge influence on them. So they will be influenced by the large landmarks. So if you're walking through a town square, large billboards will, if they suddenly move it to the other side of the square, your whole representation, these cells will change. But the geometry is the primary thing that seems to operate on these cells. And in fact, someone I was working with my PhD discovered, he's a clever maths chap, that he could come up with an equation that explained exactly how these cells would fire if you change the environment, if you expand the rooms. And it was a very simple idea. It's just a summation of the distance between the middle of this thing and the wall in 2 different directions. And it was an incredibly long maths paper, but it's just as simple as that. If you expand the environment, this cell will essentially, most of the time, still fire in this, as we say, fire, will respond, will be more active when you're in this bit of the space. You can sometimes get cells with 2 peaks, and depending on where you're looking in the brain, you can get all sorts of different types of representations. There's another type of cell which I think is quite interesting that are known. So these are known as place cells. This is the idea of places. There's also cells in your brain, and every animal, mammalian brain that we know, have these cells called head direction cells. Rather than representing places, they represent which direction you're facing in. So in terms of north, south, east, and west, you'll find these cells, as I move around this room, as I face in this direction, a particular set of cells may become very active, and then I turn away, they'll become very less active. Whereas another set of different cells, in a region very similar, very near where these cells are located, will be more active. So you can represent the whole compass around yourself, and it's not just it. This representation of angle, again, is very much influenced by the geometry. If I now change the walls and I move landmarks around, my representation of what was the north cell will now shift. It'll change. And so we have this incredible system in our brains for representing distances, places, angles, all of these things. But it's at quite a high level, and people are really trying to peer and ask the kind of questions you're asking, which we don't really have the great answers at the moment.
So, for instance, if like someone left Japan, Tokyo, just before the war, and they went back after the war, it was completely obliterated, and they're looking for the place that was their home. Even if there's none of the geometry left, there's none of the actual objects that made that space, would they still have something being triggered?
That asks another interesting question. They might well do. There's another system. You keep asking questions and bring up other systems in the brain. There's an idea that if I close my eyes and walk over a particular place and come back, I can remember exactly how many footsteps. It's not so much the footsteps, but the locomotion that I've moved. This is called the path integration system. You can represent changes in your bodily motion, independent of vision or angles or all these things. It's just simple. It's a system that, and it can work out if you go in all sorts of different places. The shortest line back. So ants are incredibly good at this. And a lot of people have studied ants. So it's possible that this woman went back to Tokyo or to somewhere that was incredibly changed, and she got off at some tube station or somewhere that she knew. She might be able to remember, if I walk a certain distance, may not be, they don't have to say 100 yards. They literally feel it, an instinctive distance. They may be able to get back to where they were. But that system is notoriously unreliable, so I'll be very surprised. But then again, you never know. So there's lots of things driving the way our brains process space. It's not a single entity. There's lots of ways we can think about space. But yeah, as a neuroscientist, we don't ask these kind of interesting questions a lot. So it's great to come and get architects to go. Sorry?
You know the direction cells.
Yeah.
Some magical person somewhere is a human compass, and it's not affected by the geometry.
Sorry.
Wherever they have the same direction cells being triggered in the same universal direction.
Yeah, it's possible that somebody, I certainly hear of this. I met someone who said, yes, I have an incredible sense of magnetic north. It's quite possible, they do have some. Well, I don't know. I don't think we, as far as we know, humans don't have a sense of magnetic north. We don't have that property. Like salmon for sure do. But some people seem to have an uncanny sense of updating their knowledge, I think. Certainly taxi drivers after 40 years living in London certainly know exactly which direction everything is without having to really think about it.
Very practical.
Yeah.
Do you have a website?
I do, yeah. I think if you just type my name into Google, you can hit my, So if you look at the posters, well, I should really run off and update that website now.
Can I ask a quick question? I'm not sure if it's a question for neuroscience or psychiatry, but it's just about the landscape. Is that landscape a kind of remembered whole, so like a memory of the complete landscape, or is it a montage of bits of landscapes? Is that known, or is there research into that, or?
Yeah. It does make sense, and it's the kind of one that psychologists ask, and they say, how do we represent a whole city? Is it one big thing? How do you parcel up the space? And I don't think there's a very clear answer to that. There's a lot of literature, people asking this type of question, I think there's a lot of evidence that you categorize different spaces, so it's quite useful to think about neighborhoods. Like Bloomsbury, you can think of the whole neighborhood around there and its relation to other neighborhoods. So there's many, many levels to way. So whether there is an entire whole, I'm not sure it's an easy question to answer, but it's certainly an interesting one. I don't know about psychiatry, whether people can, there's some strange.
I know there's been a lot of research, but there's no conclusive.
I think there's some strange cases where people believe that their house has been destroyed and a complete replica house has been recreated, and they're now living in this. I can't remember the name of the term. It's paramnesia or something.
Yes, they sometimes believe themselves.
That they have been.
They have died, and someone else has taken their place. Yes, I find that.
Or that people think people exist that haven't existed, that don't exist, but where that person that they're imagining might be someone else or a
I'd love to know. I've wondered that myself, and I never heard of anyone trying to look at that. Apparently, what I understand, these patients who lose all sense of their own body position, it's a terrifying experience. They really hate. They hate going to sleep. They always have the lights on all the time, because it's just horrible, apparently. But I think they have no problem finding their way around because their visual representation in the outside world is okay. So they can go to the shops, they can come back, they can do all these things, but they can't, without their eyes, tell you where their hand would be. It's very strange, that phenomenon. Yeah. But I think it's a very different type of representation. But I don't think it's been properly tested. Anyway,
we'll have to end because it's nearly 9. We continue tomorrow at 5 o'clock, practically. Thank you very much. Oh, wow.